Welcome to G Fun Facts Online, where we dive into the most fascinating tidbits our universe has to offer. Today, we're setting our sights on a celestial neighbor that's often called Earth's twin, Venus. Similar in size and composition to our own planet, Venus has long been a captivating enigma, wrapped in a thick, scorching atmosphere that hides its secrets well. For decades, the prevailing wisdom was that Venus was geologically dead, a stark contrast to Earth's constantly shifting, plate tectonic-driven surface. But hold on to your hats, because recent analyses, primarily digging back into data from NASA's Magellan mission in the 1990s, are painting an entirely new, vibrant picture. It seems Venus might be far more geologically alive than we ever imagined, offering us a unique window into how planets evolve, and even a peek into Earth's own distant, fiery past. Now, it's important to note that Venus doesn't have Earth-style plate tectonics, where massive crustal plates jostle, collide, and recycle. But don't let that fool you into thinking its surface is static. Far from it. Evidence is mounting that Venus experiences ongoing deformation, primarily caused by molten material surging up from its interior. This activity is especially noticeable in some truly unique and colossal features called coronae. Picture these: vast, almost circular structures, stretching from dozens to even hundreds of kilometers across. Scientists believe these enigmatic formations are the surface expressions of hot, buoyant plumes of material, rising from Venus' mantle, pushing up against and warping the planet's rigid outer layer, the lithosphere. You'll often find concentric fracture systems ringing these oval-shaped coronae, hinting at the immense forces at work beneath. So how are scientists uncovering this hidden activity? It's a fascinating detective story. Recent studies have been leveraging sophisticated 3D geodynamic models and meticulously re-examining Magellan's gravity and topography data. By combining these datasets, researchers can effectively peer beneath Venus' cloudy veil. Gravity data in particular has been a game-changer, allowing scientists to detect less dense, hot, and buoyant plumes lurking under the surface, details that topography data alone just couldn't reveal. In one recent eye-opening study that looked at 75 different coronae, an astonishing 52 of them showed clear indications of active subsurface processes. This strongly suggests that tectonic and volcanic activity might be far more widespread on Venus than we previously thought. This hidden activity seems to manifest in several intriguing ways. One proposed mechanism is a kind of Venus-style subduction. Imagine a mantle plume pushing upwards, causing the surface material to rise and spread out. This outward pressure can then force the surrounding crustal material downwards, back into the mantle. It's somewhat analogous to subduction zones here on Earth, but operating in a distinct way without those large-scale tectonic plates. Another process potentially shaping Venus is something called lithospheric dripping, where cooler, denser sections of that outer lithosphere sink back down into the hotter mantle. And of course, these powerful mantle plumes can also drive volcanism. Molten rock can push through thinner areas of the crust, erupting onto the surface. In fact, separate research has already identified evidence of recent volcanic eruptions on Venus, including vast lava flows from prominent features like Mont Mons, Sif Mons, and the Isla Regio area. All of this builds a compelling case for an active, breathing Venus. The implications of these discoveries are genuinely profound. Understanding the internal processes that shape Venus' surface is a fundamental goal for planetary science. The presence of ongoing geological activity tells us that Venus still retains significant internal heat and is dynamically active today. This completely challenges the older view of Venus as a planet with a uniformly ancient and unmoving crust. And the story gets even more interesting when we look into Venus' past. Some research suggests that Venus might have even had a form of plate tectonics billions of years ago, much like early Earth. Atmospheric data and computer modeling indicate that the current composition of Venus' atmosphere and its immense surface pressure would only really be possible if an early form of plate tectonics had occurred sometime after the planet formed, roughly between 4.5 to 3.5 billion years ago. This early tectonic movement might have been limited, perhaps involving fewer plates and less dramatic shifting than we see on modern Earth, but it would have been a crucial process for releasing gases into its atmosphere. Eventually, it's thought that Venus' extreme heat and incredibly thick atmosphere may have dried up the necessary ingredients for this tectonic movement, leading to the stagnant lid or single-plate crust we observe today. Studying Venusian tectonics also offers us a fascinating glimpse into Earth's own geological infancy. Those coronae features we talked about? They aren't found on Earth today. However, scientists speculate that similar features might have existed on a young Earth before robust plate tectonics really got going. So by studying the active processes on Venus now, we might actually be able to better understand the conditions and geological expressions of our own planet's early, more dynamic past. It's like looking at a planetary cousin to understand our own family history. Then there's the puzzle of Venus crust thickness. Scientists had generally expected Venus crust to have grown progressively thicker over eons, especially given the apparent lack of large-scale crustal recycling. But recent modeling suggests its crust is surprisingly thin, averaging about 25 miles or 40 kilometers, and at most around 40 miles or 65 kilometers thick. What gives? The proposed explanation involves a process of crustal metamorphism. As the crust thickens, the bottom layer becomes so dense due to increasing temperature and pressure that it either breaks off and sinks back into the mantle, or it simply melts. This process could also reintroduce water and other elements back into the planet's interior, potentially fueling even more volcanic activity. Some scientists even propose a flake tectonics model for Venus, where the crust is composed of smaller, weaker pieces that slowly move and reprocess the surface over a churning mantle. Not quite plate tectonics, but definitely not stagnant. So what's next in our quest to unravel Venus' secrets? The future is incredibly exciting. We have new missions on the horizon, like NASA's VERITAS orbiter, that's Venus emissivity, radio science, INSAR, topography and spectroscopy, slated to launch no earlier than 2031, and ESA's EnVision mission. VERITAS, for instance, will be a game-changer. It'll carry advanced radar and spectrometer instruments to create high-resolution 3D global maps and analyze the surface composition with unprecedented detail. The gravity maps from VERITAS are expected to improve resolution by at least 2 to 4 times compared to Magellan's, giving us a much clearer picture of those subsurface structures and processes, including a really detailed look at hundreds of coronae. In conclusion, Earth's so-called twin, Venus, is increasingly revealing itself to be a geologically dynamic world, far from the static, unchanging sphere it was once largely considered. The ongoing reanalysis of decades-old data, combined with sophisticated new modeling techniques, continues to uncover compelling evidence of hidden geological activity. From the active shaping of coronae by mantle plumes to potential Venus-style subduction and a surprisingly thin crust, these findings are fundamentally reshaping our understanding of how terrestrial planets evolve. As we eagerly await the next generation of Venus missions, the secrets locked beneath its thick clouds are slowly but surely being unveiled, promising even more thrilling discoveries about the inner workings of this fascinating and once misunderstood planet. Venus is alive, and it's telling us its story. Thanks for tuning in to G Fun Facts Online.